Greetings, students. Let's continue to think about how to play with proofs, to engage in the game of symbolic logic, so we can practice the rules of thought, so that we can get them down and move on to the more interesting things we do in philosophy classes. Because never forget, logic is a preparation for philosophy, but not philosophy itself. It's the philosopher's toolkit. So let's play in our toolkit, and let's think about strategies for doing proofs. Now, a strategy, as you know, is just a plan or a method for achieving a goal. And the goal we want to achieve is to take our premises and prove our conclusion. And it's really all very simple, you see. So just pay attention, and let's see what we come up with. Suppose you look at a proof, and you just can't decide where to start. In that case, you can scan the premises, looking for any lines in the proof which fit the rule patterns. When you spot one, just apply it, even if you don't see how it will lead you to the conclusion. And often, if you just start doing this repeatedly, you'll come to the conclusion without even trying. Consider, when I just start scanning the premises, I notice I have a P, then a Q right there, and I have the P, so I can get the Q. So I just do that. I don't even think about it. I just apply the rule. I then notice, since I have that not G, I could apply it to line 2 through the rule of disjunctive syllogism and get an R and a H. So again, I'm not even thinking about it. I'm just scanning the premises, looking what I've come up with, and applying rule. And then I notice, well, there's the H I'm looking for, and I can just simplify, and I have it. So when in doubt, just start applying rules willy-nilly. It doesn't matter what order you do it in, and sooner or later you're liable to come up with something you can use or trigger some intuition where you see, this is how I can get to the conclusion. So that's the method of trial and error. Sort of just throw everything at the wall and see what sticks to it. Now with the method of breaking it up, you look for compounds that you can use the rules to break up into parts. The key to doing this is to focus in on the major operators, right? There's the major operator there. So if I wanted to break something, if I wanted to break that up, well, I'd have to use a rule that involves the arrow, which makes me think of modus ponens, right? The way I could break that up is H or C would break that up, and I have an H, so I can add C to H to apply it to number 1. And that gives me this, the Q, E or F or A and B. Now if I wanted to break this compound up, I have to focus on a rule that allows me to separate things out with the V. And that makes me think of disjunctive syllogism. Notice here I have a not E or F and there's an E or F. So that's like a not P or Q, so I can get Q. So now I have an A or B, an A and a B, and if I want to break that up, well, that's easy. I got the rule of simplification, and then I recall, well, I'm looking for a B, and there's a B, so I'm really almost home. And there you have it. I simplify to the B, and I've reached the conclusion through the method of breaking it up. This final method is the one I find to actually be the most fun, because you sort of think through the proof backwards from the conclusion. So you reason about it. And that's more fun, to me anyway. Now when you do this, you make a sort of wish list. So when I look at this, I see I'm looking for an A. There's an A there, right? So if I had B then A by itself and a B, I could get my A. Right? But the only way to get the B then an A by itself is if I had a not H. So I wish I had a not H. Now there's an H there, H then E, so if I had a not E, I could get a not H. But I do have a not E. So I have everything I wish for, so I'm ready to start. So I get my not H from 3 and 5 by modus tollens. I get B then A from lines 1 and 6 by modus ponens. I get the B from lines 2 and 4 by disjunctive syllogism, And then I can get the A from 7 and 8 by modus ponens. And so I've thought my way backwards from the conclusion to the premise and sort of reasoned through the proof. So you want to approach proofs like a game of strategy, such as chess, constantly thinking of the various possible moves that open up for you at each step. Here's an example of what looks like a very complex proof. Let's look at it and think about it. Okay. I want to get not P or not F and not H. But you never want to forget that rule of addition whenever you see something with a V. Because what I'm realizing here is, if I just have a not P, right, all I need is a not P. Right? If I have a not P, I can just use addition to get not F or H. Now, is there a not P anywhere? Well, there's a not P right there. Right? So if I had not O and not P by itself, I could get not P. But it's easy to get not O and not P by itself because it's joined to this by the AND. So I can use simplification, right? So I simplify from line 3 and get not O and not P. And that's from line 3 by simplification. Whoop. Then I can get my not P from line 5 by simplification. And then I can just use addition, that magical rule. Well, it seems magical, but actually in Wonderland it makes perfect sense. And in Wonderland they think logically. If you have one true thing, you can connect it with a V with anything you want. No matter how big or small or long or short, you can do that, says the caterpillar as he puffs on his hookah. So I can just add not F and not H because the truth value is preserved. And I got that from line 6 by addition. Then I want to neaten up the way my proof looks, because that's just the way I roll. And I've done it. I've gotten from these premises to that conclusion. Consider this one. Right? If either Socrates continues to practice philosophy or he refuses to betray his principles, then he has to drink the hemlock. If he has to drink the hemlock or he gives up the practice of philosophy, then either he dies in shame or he dies with integrity. Whoop, I got to jump up to the board and add something in. All right, there we go. But Socrates continues to practice philosophy and does not die in shame. So Socrates dies with integrity. Now there's our translation. Premise 1, if S or R, then H. Premise 2, if H or G, then D or I. Premise 3, S and not D, therefore I. So let's think backwards and make a wish list. I want an I. So if I had D or I by itself and a not D, I could get an I. Well, I got a not D there, so I can check that off. Right? And if I had H or G, I could get D or I, so I need H or G. So for that, I need an H. To get an H, I need S or R. To get S or R, I could get S or R with an S, and there's an S right there. So I'm all set. So the first thing I'm going to do is just break out my S and my not D, since I'm going to be needing them. So I got S from 3 by simplification. Got not D from 3 by simplification. Now I can get S or R from 4 by addition. That'll give me H from 1 and 6. modus ponens. And I can get H or G from 7 by addition. Now I can get D or I from 2 and 8, modus ponens, and now I can get I from 5 and 9, disjunctive syllogism. And I have my proof. So that's how that works. You've got to practice the problems in the text, mull it over, come to class, and I'll have lots of problems for you to do and examples for us to go over. And don't forget our tutor, who you can contact if you find yourself extraordinarily puzzled. And of course, I'll be happy to talk with you as well if you're extraordinarily puzzled. So I'll see you in class. Thank you for your kind attention.